This is the second part of the program solving process, and we're going to pick back up with the cost of errors. We finished up with that at the end of the first session, and we're going to go back to that, do a quick review, and then get started again. Remember that there are 5 steps of the program solving process. The first one is to define the problem. The second one is to design a solution. The third one is to do it, develop it, write it, and then the fourth step is to go through and to debug and test it. And that's where we are right now. The fifth step will be to document and maintain, and we'll get to that in just a minute. So let's go to the cost of errors, which is where we finished up at the end of the first session. As we go through, the cost of finding and correcting an error during the define stage. A lot of times it's just like a blueprint where you just go through and you erase a line and then you draw another one over, maybe a foot over. That there's not much of a cost associated with that. And so when you're defining the blueprint, there's not much of a cost there. When we go through and we find and correct an error during the debug stage, say you built a house and you've already put a wall up, and you decide that you want to move this wall over by a foot. Well, you have to take the old wall down, put the new wall in, and put it up. And so there is some cost associated with that. And then the last stage is that after the program's been placed into general use, after you're using this building and you have to shut down your business for a while so that you can move this wall over, you've got some other costs that are associated with that. And so as we go through and we find out that there is a considerable cost of errors, if we can correct it early in the stage during the define stage, it doesn't cost very much. Then when we get to the design stage, which is over a little bit over here, then that costs a little bit more. And then once we get to the do it stage, it costs a bit more than when it's actually in production out here. Then the cost of that error is going to be very expensive. Sometimes they're on the millions of dollars. In the HMS Sheffield, the cost of finding an error there was the loss of about 30 people's lives. So problem solving involves getting rid of the mistakes, and it does involve a process called egoless programming. This is a team concept. It involves structured walkthroughs. You go through and you put your program out there and people look at it and they say, well, I think this will work or this won't work because. And they can actually be very uncomfortable sometimes for the programmer who's trying to defend his work. But you have to get to the point where you realize that they're giving you a useful critique. They're not criticizing you. They're trying to make the program better. If you can, if someone can say something and I can improve my program so that it doesn't cost someone to lose their life, then it's worth it. Okay, so once you get out and start working with the program, then there are some conversion techniques. In a direct conversion, you go immediately from one system to the other system. You leave the office on one day and you come back the next day and you're on a different system. Obviously that's a very risky, sometimes that's all you can do. Sometimes we just call it the plunge. It's a lot like buying a car. You drive your old car onto the parking lot and you take off with a new car. But there are other processes called the parallel. It costs about twice as much because you run 2 systems in parallel. The old system is running, the new system is running, and you run them at the same time during the conversion technique as you convert over from one program to the other. And the phased, if it's a large department, you can go from one department to another department. A hybrid, between the parallel and direct, is the pilot, where you try it out for a week and then you go back to the old system, and you try it out for 2 weeks and you go back to the old system. All of these are different ways to do it. to convert from one program to another. The summary of the errors. There are types of errors. We talked about grammatical, syntax, logic, classic errors. We gave several examples of those, and there's more written material that goes along with that. We talked about the cost of errors, and we talked about ways to prevent errors, having people review our work, the alpha team and the beta team. The last step in the process is to document and maintain. It's often forgotten. People don't pay too much attention to it. It's actually one of the most very important. This is when manuals are written. The challenge with manuals is that they are written by people who know what they're doing, and they're read by people who don't know what they're doing. That's the reason they're so hard to read, is because they're written by people that know what they're doing and read by people who don't know what they're doing. So the 5 D's of problem solving: define, design, develop it, do it, debug and test, and document and maintain. And I'd just like to go back and say that I hope this has been useful to you. Again, problem solving is a very important skill. And if you have the logic skills that are needed to problem solve, then it will help you no matter what business, no matter what career, no matter what you go into. And so I want to encourage you to go over the material that's in this section of the course, study it, read over the classic errors. If you have any questions about it, then send me an email and I'll be glad to look at it with you or answer questions. So, have a good day.